Hi, my name is Mary Poffenroth. I'm an adjunct professor of biology, and today we're going to have a little fun with Mendelian Punnett squares. Now, before we get started and jumping into our Punnett square problems, let's set down some ground rules. First, we're going to talk about alleles. Alleles are going to be like different flavors of genes. So, you go into the ice cream shop, there's 31 flavors of ice cream. Even though they're all different flavors, they're all still ice cream, right? Alleles are going to be those different flavors of genes that you have available to you. The next thing I want to talk about is dominant and recessive. In any relationship, some of those alleles are going to be dominant and some of those alleles are going to be recessive. Those dominant alleles, if they're present, they're going to have more of a say in what the outcome of that cross is going to be. And the recessives, well, they're going to have little to no say unless there are two recessives that are available. Also, in each of our crosses, we're going to have one allele from our mother and one allele from our father. Now, let's jump into our crosses. Today, we're going to do a 4-square Punnett square. So, you want to start out by just drawing a square. In that square, you're going to draw a line right down the middle from the top to the bottom and a line from left to right. Now, you have 4 individual squares. Each of those squares is going to be a probability, and each of those squares is 1/4, right? Or 25%. Next, we're going to put our parents' alleles on the Punnett square. Now, it doesn't really matter if you put male or female on the top, but generally people put male on top, female to the left. For our problem today, we're going to use eye color. The eye color alleles are going to be, for our father, it's going to be brown phenotypically expressed alleles. That means that that father has brown eyes, but his genotype, or the genes at play, his alleles are going to be big B, little b. That means that he's heterozygous, or he has 2 different alleles for that trait of eye color. It's a little important to note at this time that all of these letters are completely arbitrary. You can make up any letters you want. However, in any relationship, a capital letter or a big letter, like say big B, is going to be for the dominant. And a little letter, or a lowercase letter, in this case little b, is going to be for the recessive. Okay, so we have the father. Big B, little b. He's heterozygous, meaning he has 2 different alleles. What about the mom? The mom has blue eyes. So phenotypically, her expression that you see on the outside is blue eyes. Her genotype, or the genes at play, are going to be little b, or homozygous recessive. Alrighty, it's time to do our cross. Now, we're going to take one from the top and one from the left, and we're going to bring them down into those squares. So, we have on our top, big B, little b. Then bring another big B, little b down. In our right square at the top, we have little b. And our bottom right square, we have little b. Okay, what does that mean for the probability of getting an offspring with what kind of eye color? Now remember, each of those squares is going to be 25%. So, we have a 25 plus 25, or 50% chance of getting an offspring with brown eyes. And we have a 25 plus 25, or 50% chance of getting an offspring with blue eyes. And for a fun little extra problem when you're sitting around the dinner table, take the eye colors or the phenotypes of your parents. Even though you won't know the exact genotypes or the genetic makeup behind what you're seeing on the outside, do some crosses and see if you could find out the probability that you could have actually had a different eye color. Thanks for watching, and if you want to learn more about this subject, click on the link below. Or if you want to learn more biology, feel free to click on